Good morning, Integrated 3. Today we're going to be solving three variable systems. So it's a lot of similarity to what we were doing with our review on Thursday, Friday. I'm trying to remember what day that was. I think that was our last day on Friday. The main difference is that it's just going to be a few extra steps that we got to get the hang of. But the keys, the math that we're doing is going to be very similar. A lot of the same steps, just an extra little application that we have to use here. All right, so here's what our steps are. So the first thing that we're going to want to do is that this is the key. This is the big new step, is we're going to want to condense it down into two equations that only have two variables. All right, so what we're going to basically have to do is find a way to eliminate one of these variables. And then the step two is we're going to solve the system for both of its variables, right? Because that's what we already know how to do, right? Because as soon as that we have two equations and two variables, it's the exact same thing that we were doing on Friday. So from that point, it is going to be what you are already familiar with. And then step three is that last substitution step, kind of like what we were doing on Friday, where like you'd solve for x and then you would plug it back in to find y. This time we're solving for two variables and then we'll plug it back in to find the third one. So that's going to be your last step. All right. And then again, we'll have a bunch of examples so you'll get to see all of this. And then, so what happens is when we go back to do our substitution and we get something like this, 0 equals 1, or something that doesn't make sense, something that just doesn't work, what that means is there is no solution. And when we ever get an identity such as 0 equals 0, or 5 equals 5, or -2 equals -2, anything like that, it means it has infinitely many solutions. All right, and we'll see one example of each of those. Okay. That said, let's go ahead and get into this, see some examples of how we can solve these problems. All right, so here's our first one here. So it says solve the system. So what I am going to do is I'm going to eliminate one of the variables. All right, so it does not matter which one you eliminate, but the way that you're going to eliminate it is you're going to add two of the equations together to come up with a third equation. And then you're going to pick two different equations or a different combination and add those ones together and then come up with a fourth equation. Here's what that's going to look like. All right, so suppose I'm going to use equations number 1 and equation number 2, and I want to combine those together. Notice right off the bat, we've already actually got opposites. This goes back to Friday, so grab those notes from Friday if you want, because that has our steps for two systems of equations, or systems of two equations. So notice that if we just add those two equations together, all right, notice I'm ignoring the third one. I'm completely ignoring the third equation. We're just adding those top two together. So x and -x, that cancels out. That gives us a 0. And then the plus y plus 2y, that's going to give us a 3y. And then -2z plus z is -z. 5 and 2 adds up to 7. All right, so notice, all I did was I added those two equations together, and that gave me a new equation. I'm going to call this equation number 4, because I'm going to use this bottom one. I'm going to call that one equation 3. We haven't used equation 3 yet, though. But notice I've got a new equation, and it only has two variables in it. All right, so we got to do that again. Okay, so notice I used equations 1 and 2, and I added them together to come up with equation 4. All right, well, so now I have two options. Either I can use equations 2 and 3, or I can use equations 1 and 3. All right, I just can't use the same two again. I have to pick a different combination, but we need to eliminate that same variable. We want to eliminate x again. All right, so again, it's just a matter of what do you think is the easiest way to eliminate x. Here's what I'm going to say. I'm going to say I notice that we're really close to having opposites between equations 2 and equations 3. Again, I need to eliminate the x. Because notice, if I multiply this by 2, if I multiply the whole thing by 2, that would give me a -2x with a 2x, and then I'll be able to add those together, and I'll be able to eliminate those x's. All right, so what I'm going to do is I'm going to take equation number 2, and we're going to multiply through the whole thing by 2. I'm going to rewrite it over here on the left. That might help. All right, so think I'm taking equation number 2 and I'm multiplying the whole thing by 2. So negative x becomes negative 2x. 2y becomes 4y. Right, again, I'm multiplying this whole thing by 2. And then z becomes 2z. And then instead of equals 2, that is going to be equals 4. All right, and then my equation 3, this guy down here, we're just keeping him as he is because we don't need to change it, right? Because my negative 2x and my positive 2x, they're already going to eliminate each other just like we want. So I'm just going to rewrite equation number 3. 2x plus 3y minus z equals 9. Awesome. All right, and now we can just add these equations together. And once again, we're going to eliminate the x's. So these guys cancel out. That's a 0. 4y plus 3y is 7y. 2z minus z is just 1z. And then 4 plus 9 is 13. All right, we can drop that 0. That's not doing anything. And there I can call that my equation number 5. So look what we just did. All right, we're going to get some more practice with this. Don't worry. That was the trickiest step right there. From here, it's a lot more like what we've been doing. But now I've got 2 equations with the same 2 variables. That's the key. It's got to be the same 2. Notice how I eliminated x both times. You got to eliminate the same one. So now I've got 2 equations that both have a y and a z in them. So now it's just like what we did on Friday. We can go ahead and see what we can do here. I'm going to rewrite these down here. My equation number 4 right next to each other. 3y minus z equals 7. And my equation number 5 that I created, 7y plus z equals 13. Well, this is awesome. Look at that. If you notice, we've already got opposites right there. We actually don't even have to do anything to create it. We've already got our opposites. Again, I'm talking about those notes from Friday when we had opposites. What do? We just add those equations up as it is, and it's going to eliminate that variable. So let's go ahead and do that. We're just going to add them up. 3y plus 7y is 10y. Z and a negative z, that cancels out. 7 and 13 makes 20. There you go. So now we can solve for a variable. Divide both sides by 10, and we have found our first variable. Y equals 2. Okay, this is where it gets a lot easier. We're just going to start plugging stuff in. So we're going to take that, and we need to plug it in to one of our 2 variable equations, because now we can find z. Remember, once we condense it down to 2 variables, it's just like what we were doing on Friday. Okay, so I'm going to plug it into the top one. It doesn't matter which one you plug it into. I'm just picking the top one. So I'll say 3y. Oh, instead of y, right, I'm replacing that with a 2. So it's going to be 3 times 2 minus z equals 7, right? I'm just copying that guy down there, but I'm replacing the y with a 2. So 3 times 2 is 6. So I've got 6 minus z equals 7. I can subtract my 6 on both sides. Don't forget that's a negative z equals negative. Oh, no, that's a positive 1. 7 minus 6 is 1. And then we can divide by negative 1 on both sides. Get that negative out of there. So that would be positive z equals negative 1. All right, so now we've got 2 variables. And again, the last step, that's step number 3 here. We're going on to step 3. Substitute it. And then we are going to solve for the one remaining variable. Substitute into one of the original equations. So when we say original, right, that's these guys. That's those ones that we started with. Right, I know y, I know z. I just need to know x. It doesn't matter which one, but I'm going to do the first one. So I've got x plus y minus 2z equals 5. And then in place of x, we don't know that, so that's our x. Y is 2. So I'm going to replace that with 2. And then minus 2 times z. Z is negative 1 equals 5. All right, so that becomes x plus 2. Negative 2 times negative 1 is a positive 2 equals 5. 2 plus 2 is 4. Subtract 4 from both sides, and we have got x equals 1. All right, so there you go. There's your solutions. X is 1, y is 2, and z is negative 1. Okay, so in my opinion, the trickiest part is that very first step where we've got to eliminate you've got to eliminate a variable to where we have 2 equations and 2 variables. Hopefully from there, it's getting a little bit easier. If it's not, go ahead, check the Friday video, check those notes, because you got to get good with that. And if you're struggling with that, it'll be a lot harder to grasp this. So I recommend checking that first. All right, Got some more examples here. So we're going to that first step, thinking about what variable does it look like it would be really easy to eliminate. Well, here's what I'm noticing. My equation 1 and my equation 3, I've got opposites on the z. So that's going to make it really easy to eliminate z. All right, always look for opposites, because whenever you have opposites, you can just straight add those equations together, and it gets one of the variables out. So we're going to add those together. So I got 2x plus y minus z equals 9. All right, I'm copying this one, and then I'm going to copy my equation 3. 5x plus 7y plus z equals 4. We're going to add those together. You get 7x. You got 8y. Z's cancel out, and that's going to be a 13. Okay, so I used equations 1 and 3 to eliminate z. So again, we eliminated z. So that means my next combination needs to also be for the purpose of eliminating z. But I can't use the same combination. Otherwise, it'll give me the same equation. That's not going to do me any good. So I can't use 1 and 3. So I can either use 1 and 2, or I could use 2 and 3. All right? So what I see right here is that if I'm going to call this my equation 2, right? I see that these guys have the same sign. I tend to prefer opposites when I'm eliminating. I think opposites are easier because then you can just add up the equations and it'll cancel out for you, right? So what I'm going to do is 1 and 2, right? Because I used 1 and 3, and I can't use those same 2 again. I have to use a different combination. So I'm going to combine 1 with 2 this time instead of combining it with 3. But right, as it stands, that's not going to eliminate it for us, right? That's not going to do the job we need it to do. We need that negative z. We need this guy right here, well, to be a negative 2z, right? So that way it'll eliminate with that positive 2z, or it'll cancel out. So what I'm going to do is we're going to multiply equation 1. We're going to go all the way through, multiply it by 2 on both sides. Okay? So imagine we're multiplying this guy by 2, and that's going to give me 4x, right? 2x times 2. And then y times 2 is going to be 2y. Negative z times 2 is negative 2z. And then 9 times 2 is 18. All right, so that's my new equation 1. Okay, because now I can use that alongside equation 2, and I can eliminate z. And then that's going to give me another 2-variable equation where z's gone. Okay, so let's write my new equation 1 that we created. 4x plus 2y minus 2z equals 18. And then my equation 2 down here, negative x plus 6y plus 2z equals negative 17. All right, and we're going to add them together. So 4x minus x is 3x. 2y plus 6y is 8y. Negative 2z plus 2z, that cancels. That is 0z. 18 minus 17 is 1. Awesome. Okay, look what we've done, right? I've got one equation here. I've got one equation right here. They both have 2 variables, and the important part is that we eliminated the same one, right? Like if I take out x the first time, I got to take out x the second time. So I took out z the first time, right? There's no z over here, so I had to take out z the second time. Otherwise, it's not going to help you get anywhere. So make sure you eliminate the same one both times. Anyways, let's see what we've got. I'm going to write these down here and see what we think we can do. So I'll say 7x plus 8y equals 13. I'm going to write this one. 3x plus 8y equals 1. Again, we're solving a system of equations just like we were doing on Friday. So you want to look, do we have opposites? No, we don't. Do we have any of the same? Yes, we do. And remember, when you have the same, you can just multiply everything through by negative 1, and that's going to make it opposites. And then you can just add them together, right? This is that notes. Hopefully you took notes on Friday, right? Because when I'm using these same opposites, right, that's talking about what we did on Friday. Okay. So I see those y's. Again, those are the same sign, right? They're the same coefficient, specifically, is what we're worried about. They got the same coefficient there. So if I multiply this bottom one through by negative 1, right, that's going to change all of the signs. So if I multiply by negative 1, this would become a -3. That plus 8 is going to become a -8. And that plus 1 is going to become a -1. Now, we can add those together, right? It is always okay to multiply or divide by whatever you want, as long as you do it on both sides. That's okay. It's how you can algebraically manipulate an equation to look like what you want it to look like. As long as you're doing it on both sides, the math will still work. Okay, so let's add these together now. 7x minus 3x is 4x. 8y minus 8y, that's our key there, right? That's why we multiplied by -1 to eliminate. Now it's going to eliminate, and you get 4x equals 13 minus 1 is 12. And there we go. We've got our first variable. Divide by 4 on both sides. You've got x equals 3. We're going to plug that back in, and we're going to find y. So 7 times 3 plus 8y equals 13. All right, I'm just plugging into my first one. I've got 21 plus 8y equals 13. Subtract 21 on both sides. I've got 8y equals -8. And then we'll divide by 8. And you're going to get y equals -1. All right, and again, that final step, remember we found x and y, but we're not done yet because we got to find z. But it's not too hard. You just plug it back into one of our original equations. It doesn't matter which one. I'll plug it into this one. I'll plug it into equation number 3. So I've got 5x, but x is 3, so it's going to be 5 times 3. Plus 7y. Y is -1, so 7 times -1. Plus z equals 4. Whoops. Equals 4. So it'll be 15 minus 7 plus z equals 4. 15 minus 7 is 8. Plus z equals 4. Subtract 8 on both sides, and you will get z equals -4. And there we go. All right, we got another one. And then we can move on to the other type of examples where we have either no solutions or infinite solutions. Okay, so I'm going to see what looks like it would be easy to get rid of. I'm going to say not the z's, because both a 3, a 5, and a 4 is our coefficients here. That looks like we're going to have to do a lot of weird multiplication to be able to get rid of those. So I'm not going to do the z's. So I'm actually a little bit torn here. I'm telling you my thought process. I'm thinking about doing the y's. I'm thinking about eliminating the x's. And I am going to eliminate the y's. And here is my argument for doing that. Is because, here's why. Here's why. Is because I have a coefficient of 1. Whenever you can't decide which variable is the easiest to eliminate, see if there's one with a coefficient of 1 anywhere. That one is going to be easy to eliminate, and I'm going to show you why as we work through the example. So I'm going to eliminate the y's. All right, so first of all, we don't have any opposites. But I would say the closest we could get to an opposite is if, I'm going to call this equation 1, equation 2, and equation 3, is if we look right here and right here. The only thing I would need to do to have opposite coefficients, right, a +2 and a -2, is if I take equation 3 and I multiply it all the way through by 2, right? Because then I would have a +2y up there in equation 1. I'll have a -2y down there in equation 3, and then I'll be able to add them together and eliminate. Okay, so I'm going to rewrite these over here. So I've got 4x plus 2y plus 3z equals 12. And this one, I am multiplying it by 2, right? Because I want to be able to eliminate those y's when I add the equations together. Remember, systems of equations, you're always looking for a way that we're going to add these together. Okay, so I'm multiplying it by 2. So the 6x becomes a 12x. Negative y becomes a -2y. 4z becomes an 8z. And -3 becomes a -6. All right, we can add those together now. 4x and 12x is 16x. 2y minus 2y is nothing. That cancels. 3z plus 8z is 11z. 12 minus 6 is 6. Okay, so I've used equations 1 and 3. So I can't use that same combination. I can either go 1 and 2, or I can go 2 and 3. And here's the thing. I'm going to use 2 and 3. This is the reason why. You want to use the one that has a coefficient of 1 both times, right? So notice I've used equation 3 once because I used 3 with 1 right here. right? This was equation 1. This was equation 3. I want to use equation 3 again because it's going to make this next step easier. Here's why. Shoot, I'm running out of room a little bit over here on the right. Let's see. Can I scroll over a little more? Yeah, I can. Okay. So I'm going to use equation 2 with 3. I'm going to go ahead and write down what I've got. Equation 2, I'm just copying right now. 2x minus 3y plus 5z equals negative 7. Equation 3, I'm also going to copy. Minus y plus 4z equals negative 3. Okay, because here's why. If I did equations 1 and 2, if I was working with this 2y and this negative 3y, the only way that I could get my opposite coefficients is I would have to either multiply the top one by like 3/2. We'd have to deal with fractions. You don't want to deal with fractions. You never have to deal with fractions when you are trying to eliminate, unless you introduce a fraction, and that will not be necessary. Or we would have to multiply equation 1 by a number and equation 2 by a number, and I just try to avoid that whenever we can. Less steps, more efficient, less opportunity to make mistakes. Okay, so equation number 3. Here's what I'm going to do. Remember, we want to create opposite coefficients. I am going to multiply this one through by a negative 3, right? Because if I multiply that by a negative 3, what we're wanting is for those two to be opposite, and I'm going to turn that negative 1 into a positive 3, and that's exactly what we want. All right, so I'm going to go over and write my equations over here. This top one, we're not changing, not doing anything to it. 2x minus 3y plus 5z equals negative 7. And notice, this is just equation 2, right? This is my equation 2, the one that we started with. We haven't even touched it. I've just been rewriting it so you can see where my thought process is. And then equation number 3, I am multiplying it through by negative 3 so I can eliminate the y. Remember, the reason I'm eliminating the y is because that is what we did earlier, right? It doesn't matter which variable you eliminate as long as you eliminate the same one twice. Okay, so we're going to go 6x times negative 3, negative 18x. Negative y times negative 3, plus 3y. 4z times negative 3, negative 12z. Negative 3 times negative 3 is a positive 9. All right, so here's what we got. We're going to add these together. 2x minus 18x is a negative 16x. 5z minus 12z, negative 7z. I don't know why I just wrote an x. Negative 7z. And then we've got negative 7 and 9. That's going to make a 2. Okay, so here's our new two equations we've got. I'm going to circle them in red so you can see them. 1, 2. All right. Notice we've got two equations with two variables. That's exactly what we wanted. We got the y's eliminated. Okay, so I'm going to rewrite those two equations that I have circled. I'm going to keep them in red. And hopefully what you might already be noticing is, look at this. We've already got some opposites, right? We've got a 16x and a negative 16x, right? Opposites, we're talking same coefficient with the opposite sign. Plus 11z equals 6. And look at that. So I can already go ahead and add those equations together, because that's what we do when we have opposites, as we learned on Friday. We've got to cancel on the x's. We've got 4z equals 8. And then we can divide by 4, and you'll get z equals 2. And once again, just like always, we're going to go ahead and plug that back in. I'll plug it into the second one. So I'll have 16x plus 11z. So that'll be 11 times 2 equals 6. 11 times 2 is 22. So I got 16x plus 22 is 6. We're going to subtract 22's on both sides. 16x equals negative 16. And then we'll divide by 16. X equals negative 1. All right, last thing. We take those two variables, put them back into one of our originals, and we're going to solve for y. I'll put it into this top one up here. I already forgot what my answers were. It was negative 1 for x and 2 for z. So I've got 4 times negative 1 plus 2y plus 3. My memory's horrible. I'm so tired right now. I already forgot what z was. It's 2. Okay, 3 times 2 for z equals 12. All right, that's -4. 3 times 2 is 6. -4 plus 6. We're going to combine like terms. I've got 2y plus 2 equals 12. Subtract 2. 2y equals 10. Divide by 2. Y equals 5. Okay, I'm sorry. I know I'm running out of room a little bit there. But again, those are our steps. That first step, get it down to 2 equations with 2 variables. Step number 2 is we're going to solve that systems of equations just like we did on Friday. 2 equations, 2 variables. Hopefully, you've got your notes from Friday. If you don't, go back, watch that video. We're going to have a few days on this. We're going to spend a good part of this week doing the same concept. So I might even make some more videos showing some more examples if that'll help. And then the third step is just plug everything back in. Okay, this video is already going up on half an hour, so I am going to stop it there before my iPad glitches out and makes me lose all my progress, and I'm going to make a second video with the second half of the notes.